back to section 4.1. We're talking about the rectangular coordinate system, and this is the second video that goes with the rectangular coordinate system. So if you didn't watch the first one, you might want to watch that first. But we talk about solutions to linear equations in two variables. And here's a very similar question that comes from the homework. Which ordered pairs are solutions to the equation? Now, remember, there's an infinite number of solutions to every linear equation in two variables, so you really just have to check these one at a time. So remember, always x comes first and then y. So in the first choice, I have 3 times 2 plus 2 times 0. Does that equal -6? Well, that gives me 6 plus 0, that does not equal -6, so 2, 0 is not a solution. And I'm going to work my way down every one of these to determine if we have a solution or not. So the next one, I have 3 times 0 plus 2 times -3, is that equal to -6? We know 3 times 0 is 0, 2 times -3 is -6. Is that equal to -6? Sure is, so 0, -3 is a solution. Now I check -2, 0. Is there a quicker way to do this? Nope. Okay, you do have to check all these individually. So I've got -6 plus 2. Oh, I forgot to plug in y, didn't I? That's a 0. Okay, plus 0. Does that equal -6? Sure does. So the second one is also a solution to this linear equation. Let's try 0, 3. So 3 times 0 for x plus 2 times 3 for y. Is that equal to -6? It is not, because that's 0, right? 6 equal to -6? Nope, not a solution. Now we've got a fraction. Is that okay? It can be. So 3 times 1 is my x value, plus 2 times my y value is -9/2. Is that equal to -6? That is the question. 3 plus, now these twos cancel. 3 plus -9, is that equal to -6? And it is. So that is a solution. Now let's check our last one. 3 times 2/3 plus 2 times -2. Is that equal to -6? Well, these 3's cancel to give me 2. And then 2 times -2 is -4. Okay, but 2 plus -4 is -2. It is not equal to -6, so that is not a solution. So that, y'all, is how you handle these problems. You have to check them one at a time. So please don't say, oh, I found one, and be done. Because typically when this problem is asked, it asks you to select all solutions. So there easily could be more than one. Every one of them could be a solution. Only one of them could be a solution. None of them could be a solution. Or like in this case, 3 of them. Okay? And just for you, I have another one. So what I'd love for you to do is pause the video and see if you can't determine which of these are solutions. And come back and we'll do it together. Alright, so you're back. Let's try this. Remember, x is first, so 10 is your x. So is -10 minus 5 times 0 equal to 10? And my argument is no. 5 times 0 is 0. Is -10 equal to 10? It is not, so 10, 0 is not a solution. But -10, 0, let's try that. So I have negative, which is already in my formula, and then I'm replacing x with -10 minus 5 times 0. Is that equal to 10? Now negative of a -10, that is 10 minus 0. Is that equal to 10? And it is. 10 equals 10, so -10, 0 is a solution. Now I'm going to check 0, 2. X is 0, y is 2. So -0 minus 5 times 2 equal to 10. Is that a true statement? Well, it's not, because this says -10 is equal to +10. That is not true. Okay, missed the line. Let's try 0, -2. So 0 is my x, so -0 minus 5 times -2, is that equal to 10? Well, this is just 0, but -5 times -2 is +10, and that equals 10, so 0, -2 is a solution. So let's try x equals 5 and y equals 1. So it'd be negative 5 minus 5 times 1. Is that equal to 10? It's not, because negative 5 minus 5 is negative 10. And that is not equal to 10, so this is off. Now don't automatically assume the last one is true. It may or may not be. You got negative of a negative 5. Remember, x is negative 5, but there's a negative in your problem. That's why we need both negatives. Minus 5, remove the y, replace it with negative 1. Is that equal to 10? Well, negative of a negative 5 is a positive 5. And then this negative 5 times this negative 1 is a plus 5. Yep, that equals 10. So there we go. Again, that one just happened to have 3 solutions. When you see this problem, don't assume that half of them are and half of them aren't. You just never really know. So now we're ready to talk about something called the rectangular coordinate system. All we have discussed so far are solutions to linear equations that are in 2 variables. So remember, we talked about how many solutions these have. And there's an infinite number of solutions. So if you think about it, there's no way in the world to list all the solutions. Let me go back and show you an example real quick of, let's just say this problem right here. This is in the previous video, but notice we've got 3 solutions listed on the far right over here. All 3 of these in the far right column are solutions, but there's an infinite number of them. So we could pick other x values to plug in, like 2, 3, 4, 5, 100, 1,000,000, or negative 576. They would all give us a unique solution. So there's actually no way to list all of these solutions because there's an infinite number of them. So instead, what I want to do is graph these on a rectangular coordinate system. Okay? So what I'm going to do is show you your very first rectangular coordinate system. It's real simple. A rectangular coordinate system is a horizontal number line. And you've seen these before. Remember, they go forever in both directions. Zeros in the middle. And then we have 1 and 2 and 3 and 4 to the right. And it continues forever. And to the left, you have negative 1, negative 2, negative 3, and of course negative 4, and it keeps going to the left forever. But now that's just a number line. But here's what we're going to do. We're going to put a vertical number line right on top of it. Okay? Now 0 is still in the middle right here, and when you go up, that's 1, 2, 3, 4, 5, and then when you go down, negative 1, negative 2, negative 3, negative 4, of course, negative 5. And there is what we call your rectangular coordinate system. It's also called an XY axis. You can even see it called a Cartesian coordinate system. They all mean the same thing. When you call it an XY axis, it's a little more restrictive, but the reason it's called that is because the horizontal, that's often your x values, whereas the vertical is your y values. Okay? So I would rather, instead of drawing one every time, because you see how unruly they can get, I'm a little better at it when I draw on paper instead of a squirrely computer screen, but still, it's kind of a mess. And so I put them in for us. So let's check out the next page. Look at there. Okay, there's 2 different versions of a rectangular coordinate system. I could give you one that just has the lines drawn already, the x-axis and the y-axis. And again, we call the horizontal one, typically we call that one the x, and this one the y. If you'll notice, it doesn't have the arrows to the left and down. That's okay. You'll see a lot of coordinate axes that don't have arrows the other way, but that doesn't mean they still don't go forever the other way. They do. Okay? And then, but a problem like this, you could put your own scale. You could say this is 1, 2, 3, 4, or you could even say, hey, that's 5, that's 10, that's 15, that's 20. Now the other way, you'd have to use the same scale, negative 5, negative 10, negative 15, and negative 20. I should have these the exact same distance apart. I don't always. Now the y scale does not have to match the x scale. So you could say that this is 2, 4, 6, which would make this negative 2, negative 4, negative 6. It really depends on your needs. Okay, so the x scale and the y scale don't have to match, but they do have to be consistent. Whereas if my first mark is 5 on the right, then my next mark to the left must be -5. I can't say this is 5 and this is -1. That wouldn't make any sense, right? Now, the most of the time, I'm going to give you an XY axis like I have here on the right of the page, where it's all marked off for you. So the X is the horizontal. Notice the only ones that are listed are 2, but every line is 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and go backwards the same way. Whereas on the Y scale, which is up and down, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then you go down the same way. So both of these are Cartesian coordinate systems or rectangular coordinate systems or an XY axis. Sometimes you fill out the scale yourself, and sometimes it's already done for you, like the one on the right. Now what I want to do is show you how you plot a point on a rectangular coordinate system. So remember, a point is always an ordered pair. So I have 3, 4. So remember, x comes first and then y. So my x value is 3 and my y value is 4. Okay, so the point is just a single point. You need an x and a y to plot a single point. Is the intersection of both of those. So let me show you what's kind of highlighted here. Okay, so x is 3. So always start in the middle, and I'm going to count over. X is the horizontal, right? If x is 3, I count to the right because it's positive. So here is x equals 3 right here. Now, it's not on the line, but it's actually anywhere along, oh goodness, sorry about that, anywhere along this line is x equals 3. Okay, so all of these are x equals 3. Now, in, let's say, yellow, I'm going to do y equals 4. So I start here, and there's y equals 4 along the y-axis, which is vertical. So there's y equals 4. Everything up there is y equals 4. Now, your answer, the point 3, 4, is where they intersect each other. So this point in red only is the answer, 3, 4. And you can label it right on top of it, right there. There's the point 3, 4. Now, what I won't do every time is the highlighting thing. What's easier, watch this. I'm going to do this in red. Start at the origin, okay, and count over to the right. 1, 2, 3. And then you count up to the y value, 4. 1, 2, 3, 4. And then it takes you right there. So did you catch that? I counted over 1, 2, 3, and then I count up 1, 2, 3, 4. And what I have there in red is I'm not going to mark that. The only thing I'm going to mark is my point. So let's plot some more points so we feel comfortable with this, shall we? Okay, so example I, I'm going to plot the point -2, 7. Now my x is -2 and my y is 7. So remember, always x comes first, then y, which means your horizontal is first and then your vertical is second. Okay? All right, so I start at the middle. I do not make a dot, and that, by the way, the middle is called the origin, and that point is 0, 0. So I count x is 2. So you see that's right here. I count to x is 2. I don't make a mark there, but my y is 7, so I go up to 7. So 1, 2, 3, 4, 5, 6, 7. So here is the point -2, 7. Now, the question comes, do I have to buy a graph paper for this class? You do not. You can draw your own, like the squirrely first one that I did, but you may want to buy some graph paper. It's helpful. And I'll try to remember to send you some that you can print out as well. I have some of these same XY axis that we're plotting on right here. I will send you some of that, and you can print that out if you have access to a printer. All right, let's look at the next one. Let's do this in a different color too. In blue. Let's look at -5, -2. Now remember, my x is -5, my y is -2. Always in your mind, start at the origin, okay? If x is negative, that means you go to the left first. So I go to left, -5. It's between -4 and -6, so I'm right here, okay? But then my y is -2, so since it's negative also, I go down. So this point right here is -5 for x, -2 for y. And it's really where they intersect each other. If I'd highlighted like I did on that other page, the x is -5 is anywhere along this green line, and y is -2 is going to be anywhere along the purple, and where they intersect is my blue that I plotted, which is -5, -2. Let's try this one more time on this page. How about in green? We're going to plot the point 2, -4. So x is 2, y is -4. Okay, so if x, so always go back to the origin. X is 2. Since it's positive, I go to the right. Okay, instead of to the left. If it's negative, I go to the left. Positive, I go to the right. I don't make a mark yet. Y is -4. So positive, I go up. Negative, I go down. And I go down to -4 right there. So if you'll notice, above you is x is 2. And to the left is y is -4. And the intersection of those is your answer. So this is the point 2, -4. So to plot any point, you have to have both an x and a y value. If you ever used a road atlas before, it works the same way. You have letters and numbers to locate a city on the map, like L5. So you would go across to L, and then you would go down to 5 to find that point on the map. This is the same idea, except we're using all numbers. Now, how about you take a minute and plot these 3 points. See if you can figure out where they are. They're different because they have zeros in them. But take a minute, pause it, see if you can find all these points, maybe plot them on some paper, and we'll compare answers. So hopefully you've taken a minute to do this. So I want to plot 0, -4. And remember, the x is 0 and the y is -4. So x always comes first, and that's left to right. Well, if it's 0, that means you don't move to the left or the right. You stay right there in the middle, but the y is -4 means I go down to -4. So this point in red right here is 0, -4. Now let's try the next one in green. 3, 0, that's x, and then y. So my x is 3, so I always start in the origin. I don't make a mark, I just look there. I count to the right 3, and I don't go up or down at all because the y is 0. So this point right here is the point 3, 0. And then the last one, the point 0, 10. Let's do this in blue. So that's my x is 0, my y is 10. So I go back to the origin, I don't make a mark. X is 0 means I don't go left or right at all. Y is 10 means I just go up to 10, and right there at the top of my graph is the point 0, 10. All right, our last page of problems for this entire section. Plot the point -2, -9, and state what quadrant the point is in. Woo, something new. What quadrant it's in? Well, let's talk about quadrants. Where everything is positive, where my x's are positive and my y's are positive, the top right corner is called quadrant 1, and we just use a Roman numeral 1 for quadrant 1. And then you go counterclockwise. So on the top left over here is quadrant 2, and you're still going counterclockwise. Where everything is negative is quadrant 3. Again, just using Roman numerals. And then finally, this guy left over here, quadrant 4. There we go. All right, so quadrant 1, top right, quadrant 2, top left, quadrant 3, bottom left, and quadrant 4, bottom right. And you just count counterclockwise. So what they want us to do here is plot these points. I think it's worth a pause and plot them. When you come back, we'll see if we get the same answer when we plot. So when I plot -2, -9, I do my x first is -2. So I go to the left, -2, and then I go down right here to -9. So this is the point -2, -9, which I've plotted and labeled. Notice that's in quadrant 3. You don't have to write as a Roman numeral. If you put 3 like that, I'll be just fine with that. Okay. Now -6, 1. So -6 is my x, 1 is my y. So I go to the left, -6. I don't make a mark yet. I go up to y equals 1, and there is -6, 1. And notice that is in quadrant 2. Again, the Roman numeral or the number 2. All right, let's look at 7, 2. So x is 7, y is 2. So I go over to the right and touch 7. I don't make a mark yet because I still have to go up 2. And there's my point 7, 2. And notice that is in quadrant 1. Or I could just put the number 1. And then finally the point 8, -5. Let's make him purple. Okay, so x is 8. Y is -5. So if x is 8, that means I go to the right 8. I don't make a mark yet. The y is -5 means I go down to -5. And there is my point 8, -5. Okay, and he is living in quadrant 4 or quadrant 4. All right, I hope this was an easy section for you. The first video is really more algebra, and the second video feels like you're dealing with geometry, right? Because you're plotting points in an XY axis. Now, in section 4.2, which is coming up, you're going to combine those two ideas together and start graphing straight lines. I hope you have a wonderful day.